Hello and welcome back to our chemical bonding unit discussion. Today we're going to talk about oxidation numbers. So we talked a little bit about these in the last slide, but we're going to be able to determine them today. And so the goal is to determine the oxidation state or the oxidation number of atoms in a compound. That is the objective for the end of this video. So first, a reminder, oxidation number is the apparent charge on an atom in a chemical formula. For example, I have sodium chloride here. Sodium chloride is neutral, Na and Cl. But each of these are ions, which means that they have a charge. And so in this compound, chlorine has 7 valence electrons. Sodium has 1 valence electron. The goal is to get to 8 or 0. Remember the octet rule. So for sodium, it's easier to go and lose 1 than it is to gain 7. So it's going to lose this 1 valence electron. Chlorine has 7. It needs to gain 1 or lose 7. Easier to gain 1. So this lone valence electron here is going to float over and join chlorine. So because sodium loses 1, it's going to have a positive 1 charge, and chlorine gains an electron, it's going to have a negative 1 charge. So sodium is positive 1, chlorine's negative 1. In the case of water, I have H2O. Remember, hydrogen has 1 valence electron. Oxygen has 6. And this hydrogen also has 1. Oops. So in this case, it's easier for hydrogen to give up its 1 electron and have a charge of positive 1, an apparent charge of positive 1, and oxygen gained 2, so it's going to be negative 2. And that's what you see here. The last one. This is sulfite. And so this negative 2 charge tells you it's sulfite. So the overall charge, so these were both neutral, so my answer had to be 0. So if I take plus 1 minus 2, 1 plus 1 minus 2 equals 0. And then positive 1 minus 1 equals 0 as well. In this case, because I have sulfites, I need to get my oxidation states to equal negative 2. And so oxygen has a charge of negative 2, and there's 3 of them. So oxygen equals negative 2 because it has 6 valence electrons, wants to gain 2 more. So negative 2 times 3 equals negative 6. And sulfur, because this has to be negative 2 overall, so I have negative 2 equals negative 6 plus X. Sulfur X, add 6 to the other side, you get positive 4 for your sulfur. We'll look at this, we'll do some practice here, but that is what we're working on. Okay, there are some rules for oxidation states. These 6 rules are really important, and they make life, they help things make sense. So write these down. So first, atoms of pure elements, pure substances, have an oxidation number of 0. So if you have a single element, for example, sodium, oxygen, phosphorus, sulfur, oxidation number on that is 0. The more electronegative elements are going to gain the electrons and become negative. So that's where electronegativity comes in again. That being said, fluorine is the most electronegative element on the periodic table. It will always have an oxidation number of negative 1. If you see fluorine, you know negative 1. Unless it's by itself, then it is 0. Oxygen is the second most electronegative element, so it's going to be negative 2. Unless it's bonded to fluorine, or if it's in what we call a peroxide. So hydrogen peroxide is H2O2. And in this case, oxygen has a charge of negative 1 instead of negative 2. Hydrogen is always positive 1 unless bonding to and reacting with metals, then it becomes negative. And then again, your sum of your oxidation numbers has to equal 0 or the charge given. So if you don't have a charge, it's got to be 0. If there's a charge there, it's got to equal that. Okay, so some nonmetals that have different oxidation states. Okay, so if we have some elements that have variable oxidation states. Carbon can be negative 4, positive 2, positive 4. Nitrogen, negative 3, positive 5. Phosphorus, same thing. Sulfur, negative 2, positive 4, positive 6. Chlorine has a whole slew of oxidation numbers. Same with bromine and iodine. The most common for these is actually positive 5, which doesn't make a whole lot of sense. But 5 is the most common, but the other ones are possible. And we'll look at that here shortly. Okay, so for these, let's do some practice. I want you to find and determine the oxidation number of each atom in the compound. So you have 6. Uranium fluoride. So I know that fluorine has what charge? Answer is -1. Because fluorine is -1, and there are 6 of them, -1 times 6 equals -6. I have to get to 0 because they didn't give me a charge. So -6 plus x equals 0. In this case, x is going to be 6. So fluorine is -1, uranium equals +6. H2SO4, hydrogen sulfate or sulfuric acid. I know that oxygen is -2. I know that hydrogen is +1. I have 4 oxygens, so -2 times 4 equals -8. +1 times 2 equals +2. So I have -8 plus 2 plus x equals 0. And if you take -8 plus 2, you get -6 plus x equals 0. Sulfur has to be +6. I will let you try the rest of these, work through the rest of these, and then, so pause the video, work through those, and then when you hit play, we'll continue on to the next slide. So here are some more oxidation numbers. You can practice on these as well. So HF, H2O, CS2, carbonic acid, sulfate, iodate. This should be Cl2. Sorry about that. PI3, Na2O2, nitrite, and chloride. So try those. I have the answers on the next slide, so you actually get answers on these. So pause the video, try those, and then join me again. So here are your answers. If you got some that weren't right, or you got answers different than I did, please come see me. We'll talk it over. I could have made a mistake as well, so please don't just assume that you're wrong. But those are your answers to that. Okay, here's some final opportunity for you to practice oxidation states. So when you get this done, you are done with the video. I look forward to seeing you in class again as we continue through this unit. Thank you for your time and attention. Enjoy the rest of your day.